So we're going to continue our inequalities work by solving inequalities, this time using multiplication and division. Just like with adding and subtracting, we've done this before with equations, where when you're trying to get rid of multiplication, what do? Divide on both sides. If you're trying to get rid of division, you're going to multiply on both sides. Those same rules apply. The only difference that you are going to see here, why don't you put another big star right here? The only difference from adding and subtracting is that when you are multiplying or dividing an inequality by a negative number, you're going to flip the sign. So I can't flip the sign. You're going to flip the sign of the inequality, which means if you're multiplying or dividing by a negative in the process, then you would switch greater than, flip that to less than, and vice versa. So let's see how that looks when we run into dividing or multiplying by a negative number. We're not always going to do that because we're not always multiplying or dividing by a negative number. So see if you remember when we run into the negatives that that's going to be the case. Okay. This example right here, it says negative 4x is greater than 6. How would we get the x by itself? What would we do to both sides? Well, this is negative 4 times, right? So we're going to divide both sides by negative 4. Not a big deal. Negative 4 divided by negative 4 over here goes away. It's 1, right? Bye-bye. We bring down our x. Now, here's where we have to be careful. Because of the nature of the negative numbers, we can't leave this as greater than. We're dividing or multiplying by a negative number, it's going to flip this sign. Instead of greater than, that's going to become less than. We'll see if it makes sense to us in a minute. Okay. And then 6 divided by negative 4. Okay, well, positive divided by a negative we know is going to be a negative. And then 6 divided by 4, 6/4, that's just a fraction. Let's leave it as a fraction, but let's simplify it. What can you do? We can divide both of those by 2, right? So that's going to be 3 halves. Negative 3 halves. Negative 3 halves is like negative 1.5. Right? So let's see if that makes sense to us that we had to flip it. If we were to think about doing a check for this, we would plug that back in, right? We can't use negative 3 halves because it can't be. It's not less than or equal to. What's something that's less than negative 3 halves? Something that's less than negative 3 halves. So pick a whole number if you want to. Is negative 5 less than negative 3 halves? Yeah, it's smaller, right? So let's plug in negative 5. Would it work? Negative 4 times negative 5. What's a negative times a negative? It's a positive, so positive 20. Is that greater than 6? Sure, that works. If we hadn't flipped the sign, though, if we hadn't done this, we would have been looking at x is greater than negative 3 halves or negative 1.5. So if we tried something out that was bigger than negative 1.5, what's bigger than negative 1.5? How about positive 5? That's bigger than negative 1.5, right? If we had put in a positive 5, negative 4 times positive 5, negative times a positive would be a negative, right? Negative 20, that's not bigger than 6. So because of these negatives, you have to flip this sign if you're multiplying or dividing by negatives, or it won't give you the right answer. So we just kind of proved that you had to do that to get the right answer. And remember, it's only when you're dealing with negatives. We won't have to flip the sign every time. Let's see if you can catch when we will. Let's look at A. 12x is greater than or equal to negative 60. Okay, how do we get rid of 12 times x? Divide both sides by 12, right? And we get x. Now ask yourself, do you have to flip the sign here? Are you dividing by a negative? No, that was just a positive 12, so guess what? You leave it the way it is. Nothing tricky there. What's a negative 60 divided by a positive 12? A negative divided by a positive is a negative. 60 divided by 12, 5. So that would be the solution here. And could we graph that? Absolutely. You'd still need to know how to graph that solution so we can see it visually. Let's try this guy. How do we get rid of t divided by 5? How do we get the t by itself? We multiply by 5. Times 5 divided by 5. See ya. We bring down our t. Do we have to flip the sign here? Did we multiply or divide by a negative number? No, just by 5. So we keep the sign, nothing tricky there. And what's 3 times 5? 15. So our solution for this is t is anything that is less than 15 would work for that. Okay. Let's try the last one over here. We're trying to get the m by itself. So how do you get rid of dividing by negative 2? You multiply by negative 2. Multiply by negative 2. On the right-hand side, negative 2 divided by negative 2. Bye-bye. See ya. Bring down our m. Now, do we flip the sign here? Were we multiplying or dividing by a negative number? Yeah, we were. Negative 2. So that means we have to flip the direction of this sign. Instead of greater than or equal to, it becomes less than or equal to, like this. And what's 10 times negative 2? Negative 20. So our solution to this one is that negative 20 has to be less than or equal to m. So you've done some examples of that. And when you do practice and homework, you'll do more examples where every time there's multiplying or dividing by a negative, you're going to flip the sign. Flip the sign. Flip the sign. All right, the other part of this is we're going to try and write some of our own inequalities dealing with some multiplication and division. So modeling these situations. And the first one starts with a checking account. This one says Catherine has $123 in her checking account. That's going to be an important number. With the extra earnings from her job, she can deposit $50 every week. When she reaches $500 in the checking account, she plans to open up a savings account for it. It says model this situation. Well, we know she's got 123, right? To model the situation, we're just going to write ourselves an inequality or equation. We'll see what happens. She's got 123 right now. What's she doing? She's putting more in, right? She's putting in $50 a week. Okay, so she's adding in $50 every week. Do we know how many weeks it's going to take her to get to her goal of 500? We don't. $50 times some number of weeks, right? 50 times W maybe. And she's hoping that in some W amount of weeks, she's going to have at least 500 bucks in there. Right? When you use that word at least, it's an inequality. Because she's hoping that this amount is going to be at least, which means greater than or equal to $500. She could get it to be exactly $500 and she'd open a checking account, or it could be more than $500 and she'd still open a checking account. So that's the model of this situation. Now, it doesn't ask us this, but what I'm asking us is how many weeks would it take her to get up to at least 500? Let's see. Let's solve this. Now, this is actually going to be a two-step inequality. We'll do some more practice with this next, but I think you guys can see what to do. Right? How do we get rid of everything except for the W? Let's get rid of the adding, subtracting first. Subtract 123 from both sides, right? See ya. Bring down the 50W. Now, have we multiplied or divided by anything, by negative numbers? No, so we don't need to worry about flipping the sign. Well, let's see. What's 500 minus 123? That's going to be 377. And now we're trying to get the W by itself, so divide both sides by 50. That goes away. I'll bring it over here. W, do we need to flip the sign here? Did we multiply or divide by a negative? No, we just did positive 50, so the sign can stay where it was. And let's get our calculator and see 377 divided by 50, getting 7.54. So W is greater than or equal to 7.54 what? What's our unit here for this? That was weeks. So it's going to take her at least 7.54 weeks to do this. Now, she's only putting in $50 every week. She's not putting things in at the half-week mark. So in her reality, how long will it take her to do this? It will take her at least, right, 8 weeks. At 8 weeks, she'll be at or above $500. And then at that point, at 8 weeks or after, she'll be able to open a checking account, right? So that's what we would do for this one. What about modeling these situations where it's not necessarily a story problem, just changing mathematical or English words into math symbols? Okay, 3 times a number is at least 45. 3 times a number would be 3x, is at least, meaning it's at least, it's bigger than or equal to 45. There's that at least. Must be at least 45, greater than or equal to it. Would we be able to solve that? How do you get rid of 3 times x? Divide both sides by 3. Did we divide by a negative number? Nope, so no flipping signs. Right? X is greater than or equal to, what's 45 divided by 3? 15. So 3 times a number is at least 45, so our number that we start with could be anything that's 15 or bigger, and that would work. So that would be our solution. And then one more. Let's make this a little bit harder. Let's change this one here to -2. A number divided by -2 is no more than 6. Okay, so a number, that would be like our n or our x, we'll use n just for fun, divided by -2 is no more than, that's the opposite of at least, right? No more than means it can't be bigger than 2. It has to be less than or equal to, not 2, 6, sorry. It's no more than 6, so it can't be 6. It's got to be less than or equal to 6. Could it actually be 6? Yeah, it just can't be more than 6. So less than or equal to 6. To solve this one, to get the n by itself, we're going to multiply by what? Times -2 times -2, and then -2 divided by -2, see ya. Now, this time, what did we multiply by? A negative. So what are we going to have to do to the symbol? Flip it. N is going to be greater than or equal to what? 6 times -2 is going to be -12. So in this case, that would work if we picked an n that was anything bigger than or equal to -12 would make our inequality work. All right, so when you do your practice, remember that rule about multiplying or dividing by negatives. Otherwise, it's just the same multiplication that we've been doing with equations.